When I say next generation technology, you probably think of AI or machine learning. Now, machine learning is at the center of so many modern innovations, from self-driving cars and better mobile photography to weather prediction. But there are so many other technologies enabling this revolution, from the big ones like blockchain, IoT, and big data, to the smaller ones like high-performance computing and compilers. That's why this week on Tech Life Skills with Tanmay, I want to dissect the world of AI and all the pillars that enable this innovation, with a special emphasis on the intersection of software engineering and machine learning. Because what's software without the machine learning to help build it? And what's machine learning without the software to power it? We have two very special guests this Sunday. Sriram Raghavan, the Vice President of IBM Research AI, and Ruchir Puri, the Chief Scientist at IBM Research. Their experiences and pioneering effort within the fields of AI, machine learning, and more are second to none. So make sure you join us this week to find out how these next generation technologies enable next generation experiences. So don't forget to join us on Sunday, July 26th at 11 a.m. Eastern Time, when we'll be discussing and answering your questions live. Good to go. So Sriram, I've been wondering, social media, do you think it's harmful? Do you think it's a good thing? What are your thoughts on that?
Wow, great question, Tanmay. As a father of two daughters, including a teenager, that's a question I struggle with every day. But I think, like everything else, there's good and bad. In a time like this as COVID, I'm sure social media is essential for my daughters to stay connected with their friends across the globe. I would never take it away from them. At the same time, you worry. Is that too much? It's too addictive? Does it take away from other important activities that they should be doing? Like everything else, there's some pros and there's some cons.
Hey, Sriram, why don't we ask Project Debater?
Hey, Ruchir, yeah, great idea. Pros and cons. Who else are we going to ask? Project Debater.
Frankly, who better to tell us?
That's a great idea. As a matter of fact, how about we do that in 20 minutes during Tech Life Skills?
Awesome. Look
Forward to doing it.
Speaking of which, do you want to say hi to the audience?
Hey, everybody. Look forward to chatting with you all in 20 minutes.
Hey, look forward to chatting with you. Having fun.
Join us in 20 minutes. When I say next generation technology, you probably think of AI or machine learning. Now, machine learning is at the center of so many modern innovations, from self-driving cars and better mobile photography to weather prediction. But there are so many other technologies enabling this revolution, from the big ones like blockchain, IoT, and big data, to the smaller ones like high-performance computing and compilers. That's why this week on Tech Life Skills with Tanmay, I want to dissect the world of AI and all the pillars that enable Hello, everybody, and welcome to the 14th episode of TechLifeSkills with Tanmay. Hope you're all keeping well, hope you're all staying safe. Thanks for joining. And what I want to say is that there's simultaneously something really good, but also really sad about today's episode. And that is that, first of all, what's good is that we've got two very unique special guests with so much fascinating content today. But the sad part is that we don't have enough time to do all that content justice. And so today I want to dive right in. Now, we're going to be exploring the world of AI and machine learning. But what I really want to do is explore the intersection of different fields with machine learning technology. Because innovation within domains is definitely great, but the thing is, I feel like we can really enable next generation experiences when multiple different complex technologies actually work together in such a seamless way that we kind of start to take it for granted. Now, our amazing guests today are Sriram Raghavan, the Vice President of IBM Research AI, and Ruchir Puri, an IBM Fellow and the Chief Scientist at IBM Research. Now, between our two special guests, their experience is really unparalleled. It's not often you get to hear from the both of them and ask them your questions live, and so it really is an honor to have Sriram and Ruchir on the show today. And so, without any further ado, let's go ahead and welcome Sriram and Ruchir to the show. Hi, Sriram. Hi, Ruchir.
Hey, Tanmay, pleasure to be here. Hello, everybody. I look forward to this discussion. It should be a lot of fun discussing AI and all the other exciting technologies happening around us. So thank you for having me. Look forward to the conversation.
Thank you, Sriram.
Hey, the Ruchir, fun to be on this show and looking forward to the discussion spanning multiple aspects of AI and the connective tissues actually that really make it happen. So.
Wonderful. Thank you very much, Sriram Ruchir. Once again, it's great to have you on the show today. So let's dive right into what we're talking about. So now I want to start off by giving a little bit of context for today's discussion. And today, what I want to do is, of course, dive into the world of AI, but also, as Ruchir, you mentioned, that sort of connective tissue with all the other, different technologies that we've got that are enabling these next generation applications and experiences. Some of these technologies would be, for example, blockchain or cloud computing or edge computing. And of course, another sort of huge meta, sort of the fabric underneath all of this is software engineering that I really want to take a look at the intersection of. So do you think that sounds good? Are there any other sort of technologies you think would be interesting to talk about today?
That sounds fun. That's a lot. There's lots going on just in those technologies. Yeah.
Sounds great.
Sounds good. All right. So now I want to start off by talking about the world of AI, and then we'll sort of branch out from there. Now, one thing, as you know, for example, the very first episode of Tech Time with Tanmay was with IBM Fellows and CTOs Rob High and Sam Lightstone. And back in that episode, we covered quite a few different topics within the field of AI. We did a really breadth first sort of look into the world of AI. And one thing that we didn't get too deep into is the world of trust, and I want to do that now. We all know that trust is one of the most scarce resources in the world. Like, it's the hardest thing to really gain. And with artificial intelligence, how can we make it so that people are confident in decisions that are either made by AI or machine learning systems or human decisions that are augmented by AI, right? How can we make it so that people trust that machine? How can we make it so people understand the decisions that they make? So what do you think about that world of trust in AI?
So let me start, and I know Sriram has actually very interesting opinions on this as well. But key thing about trust, as Tanmay you said, is easy to very hard to gain and easy to lose. There are two key aspects I would say about trust of AI, in particular, algorithmic technologies. It's about the fairness and it's about the explanations. That if you are telling someone something as a human, I almost take it for granted that I can ask a question, and I'm going to get a response back in almost a consumable form as I move forward in these technologies. So making sure that these technologies are fair in terms of the data that they take and the modeling that they do, they actually are fair. And there are multiple dimensions of fairness, as we will go through, a little bit later on as well. But um, data is the critical part of it. So that's one which is static. When these models are built, you actually have your data, which is, unbiased in its multiple dimensions. But that's not the only aspect, I would say. It's about when these technologies are operating in real time, they're making decisions in real time. It's critical for us to ensure that the decisions that they are making are fair at that time as well. And I'll just say two sentences on that, which is, the AI is built with what is obviously known as training data. Training data is only a sample of reality. It's not a reality in itself. There is only one reality, which is when these models are making decisions. And it's critical for us to ensure these models are being fair at the time they're making the decision. So, this real time aspect of fairness, ensuring and judging the bias at that time is critical. And the second one is the corrective aspect of it, which is if they are, deviating from their defined boundaries, making sure where they are deviating and collecting that feedback and correcting those technologies as well, almost in real time, becomes critical. And the second part will be on the explainability, which is it's not sufficient for data scientists to take 3 weeks to be able to explain a particular data point or a decision, but it's important for those explanations to be in real time as well. So I think those two technologies come together to make sure those aspects, um, you know, are essential to the trust of AI. And Sriram, chime in here. I know you have
Yeah,
very.
I think those are very good points, Ruchir. So you talked about two pillars, right? Ruchir talked about explainability and fairness. Another pillar that we notice as important is sort of the lineage. Where did this model come from? What was the data? Do you know who owned the data? Who's going to update the data? Who actually create the model, right? So the lineage of how the model was created is another element of trust. And by the way, all of these are not different from how we do trust in society. We trust something which is a little bit more transparent. We trust your decision if you're able to explain why you made the decision, explainable, right? And we trust you if apparently you're not biasing towards one or the other. But there's another important dimension I think worth calling out, that the distinction between trusted AI and ethical AI. Ethical AI goes beyond technology. This is you, whether you're a company or a business, making decisions on what it is. So there is, I think, interesting science to be done we're exploring, which is if you have a policy as a company or organization you want to execute, you have all these knobs of I choose this fairness algorithm, I choose this explainability. How do I adjust all those knobs to execute on the policy that I have stated? So there is actually, I think, policy work to be done, an interesting science that says trusted AI is like the tools, ethical AI is what you choose to do, and there is a bridge to be built between the two, which is, I think, an emerging area of a lot of interest and activity.
I feel like that's really fascinating to think about, right? That's a different way to think about trust in AI, and I feel like of the pillars, for example, that you mentioned, Ruchir, right? So one of them was explainability, and I feel like explainability is one of those things that we talk a lot about in AI, but it's difficult to really pinpoint exactly what explainability means because it's different for every model, right? It's not like you can say AI is now explainable, right? It's per model, per use case, it depends, right? And I sort of wanted to ask, give me some examples of what explainability would look like in the future, maybe in terms of explainable AI, in the sense of how will humans be able to interact and understand that AI? Will we be able to create like natural language descriptions of how an AI came to a decision, or will we be able to assign certain weights or importances to different variables that are fed into networks? What would that explainability look like? How would we interact with it?
In some ways, actually, I would say we are there today, partly, I would say, which is once a model, take as an example, let's be tangible. A model that's making loan decisions, as an example. Just like if a loan officer, Ruchir applied for a loan, let's say just for the time being, the loan was denied. I'm kind of upset. I'll go call the loan officer or go to the lending institution and ask why was my loan denied. And interestingly, models are at a point, and explainability technology is at a point where you can explain that decision in simpler, consumable terms regarding your loan was denied because your income was less than X amount, and you have had an account with us in for this much time. That kind of explanations, which is explaining on the dimensions that went into the model, are actually, they are we are already there in terms of the explainability technology. But I think what is not there yet is connecting, what I would say, multiple tasks together, because the it is not just what went into the model, but there are other surrounding inputs that go into it as well, and not everything is captured as part of that model, which is giving that decision. And I think this is where the gap between the modeling technology, so it's beyond explainability, I would say, which is the modeling technologies haven't matured yet to the point where they are at the sophistication many times in which humans might be making that decision yet, bringing multiple facets and multiple dimensions of a decision making process. Business processes are quite complex, by the way. So I think, to me, it is a gap between modeling rather than explainability as much, because given the model, I think explainability technologies are, I wouldn't say they are totally mature yet, but we can explain on the dimensions in which these models are making explanations. But it is a gap in the modeling technologies, and Sriram chime in actually as well.
The other dimension, I think, is also take that same loan example. There isn't one explanation for everybody. So imagine that loan model. So Ruchir was the end recipient of the decision. He deserves an explanation. And his explanation is, what did I do wrong or right? Tanmay, you are the model developer. For you, the model explanation is, why did the model give this answer? So the explanation for you is more technical, nuanced, because you know the model, you want to improve it. Let's say I'm sitting here, I'm the loan officer. I'm the one going to convey the decision to Ruchir. The model is telling me you should deny the loan. I want to be sure that the model made this. So the explanation for me is, tell me why Ruchir is different from these other cases. Show me examples of why. So I want to convince. So there the explanation is relative to other decisions that the model made. So the other dimension of explainability is not just the how you talked about it is going to be natural language or not, but is also to who. And we don't even have the fourth person, which is the regulator. The regulator wants to ask the bank, across all the decisions that you made, are you fair, and can you explain it? So explanation is complicated. And I think that's going to be the fascinating aspect. And there's a connection to user interaction as well, how you present it. How you're going to present it to Ruchir as the recipient, average person. We know Ruchir can take deep explanation, but in this case, Ruchir is the guy who was denied a loan. It's different from explanation to Tanmay, who can deal with a lot of sophistication because he's the model. That's an interesting dimension.
I agree, and I feel like there's actually a good example in the real world, that multifaceted, internal decision making that a lot of our models make today that we don't even realize they make. And that is, I actually have a YouTube video on this that I recorded some time ago, by OpenAI, the unsupervised sentiment neuron, right? And tell me if you think this makes sense, where, just by training a neural network to generate Amazon reviews, just an LSTM, right? Just simple, classic LSTM generating Amazon reviews character by character. Internally, there was within the hidden state, there was a neuron that represented the sentiment of what it was generating that would outperform multiple other, neural networks that were built for sentiment recognition on this data set. And, the neural network was never trained to do that, but it internally starts to model all these different things and create such complex relationships that we don't even realize it's making. So, that explainability in a sense like that becomes a lot more difficult, just because of, as you mentioned, the modeling technologies that we have today.
Agree. And so that's why you see a lot of innovation in people saying, I'll build a model for the result, I'll build a surrogate model for explainability, right? That's one approach. And the other one that's fascinated me, and we've done work in the team here, is the type of explanations that are negative. You sometimes, as a human being, make an explanation. I denied Ruchir's loan. Sorry, Ruchir, we're denying your loan today for whatever reason, but it's your call. You pick that example. I denied Ruchir's loan because I did not see 12 months of payment back, right? So it was a lack of something present, which as a human being, we do all the time. It's pretty tough for the model because it's all about getting patterns out of data that exists, right? So giving explanations about things that are not present is interesting and fascinating.
And I think just on that line, Many times I'll also ask, given my loan is denied, I'll ask, hey, what could I do so that my loan can be improved the next time, which is, mathematically speaking, what is the minimum possible perturbation in my data point so that the decision moves from a unfavorable decision from my point of view to a favorable decision, which is another aspect of explainability, which is, I'm going to ask you, what do I need to do? And you will need to, again, to Sriram's point on targeted, because that perturbation in terms of moving the classification from a one class to another becomes critical depending on who is actually asking that question as well. So this is what we call contrastive explanations.
Very interesting. That's as you're talking about this, in my mind, there's so many different, ideas around the world of explainability, and I want to definitely go deeper into it. But there are some more really interesting things that I want to ask about today, and definitely if the audience has more questions about the world of explainability or trust, feel free to put them in the chat. We will be getting to those in just a bit. But I want to sort of pivot our discussion at this point, and I want to talk, zoom out from the world of AI, and talk about wording and the way we think about AI. So when it comes to like artificial intelligence, right, it's not just a single technique or algorithm as a lot of people think. It's an AI. No, that's not really the case. It's an umbrella term for many different techniques, and it's sort of like when we give a computer a task that we traditionally thought was something that required human intelligence, we end up putting it under the AI umbrella, right? So whether that's years ago, Deep Blue playing chess, previously we thought that was a task that required human intelligence, so we put it under the AI umbrella, even though it wasn't really intelligence, it was just, human crafted heuristics that would tell it where to move next. And similarly, Watson playing Jeopardy or Project Debater and all these fascinating technologies we classify under the AI umbrella, even if it's really machine learning or gradient descent or neural networks. We classify under that AI umbrella. And so the questions that I have for you are first of all, do you think the wording of the technology in the sense that it's being called artificial intelligence, do you think that's the right thing to call it? Do you think that might be misleading in a way? And also at the same time, do you believe that these techniques, even though we associate them with human intelligence, aren't truly mimicking human intelligence or even organic intelligence in a way, and are rather just adaptive mathematical algorithms? What are your thoughts on that?
It's interesting, Tanmay. I'll chime in as well. I think in many ways I would argue the word artificial intelligence is badly. It has a wrong connotation. Mm-hmm. But are we at a point to change that? I don't think so. I think it's one of those things that we're going to sort of live with and evolve our understanding. I know at IBM we talked about augmented intelligence, sort of to give that perspective. But I think the word has caught on, so we're almost sort of stuck with it. Yeah. But it does have a lot of challenges. One comment I would make is, when we talk about always comparing it to human intelligence, we should also remember that sometimes even if the inspiration for doing something is, hey, humans are able to do that, can I get a machine to do that? That's great. The how may be very different. We don't have to assume, like planes don't fly the way the birds fly. The inspiration to make flying machines could have been the birds, but you don't build it with feathers and sticks and mobility. Yeah. So I think that's the other thing to keep in mind, that human intelligence for inspiration is great. The third comment on that whole track is, it's a very philosophical question, of course, what is intelligence? But I think it goes back to our discussion with trust, that if something just spits out something that looks cool and interesting and seems right, but lacks consistency, lacks explainability, lacks the ability to adapt, very soon we will figure out that it's not human intelligence. Because what distinguishes human intelligence is you're being very adaptable. You're not stuck to, well, if my runtime data looks very different from a training data, I'm like completely, no. Human intelligence adapts. You know how to learn on the job, ask questions, acquire knowledge. So I think we all as humans know the attributes we are looking for something to be really human intelligence. But whether we will get there using the same approach or we'll build new kinds of machines, I think remains.
I think Sriram made a excellent point on adaptability. And the other one I would really say will be, resources. It's critical because resources in the world are limited. We can always brute force a problem, by the way. And anytime we brute force the problem, even though the outcome is similar, let's assume playing chess. Yeah, at the outcome it is intelligent, but the what went into it, the adaptability part of it that Sriram mentioned. But let me give a very simple data point. Your human brain consumes roughly around 20 watts and runs on sandwiches versus a single GPU. A single GPU. I'm not even talking about 1,000 GPUs that OpenAI has access to. A single GPU consumes 350 watts and is not adaptable. Just the sheer amount of inputs we are taking, the modalities that we are taking, adapting, it's mind-boggling. Actually, it's critically mind-boggling. Just imagine the scenario: 20 watts, one GPU, runs on sandwiches, adapts all the time. Like it's day and night. Actually, I think all of us know what we are looking for, and I would agree with what we just discussed. It's like artificial intelligence is like almost a misnomer, but we are stuck with it, and we will continue to use that word. But I think all of us know who've been in the area where we are in this, and how far we have to go. And it's not even clear for us, certainly not clear to me, and I think Sriram would agree with me. It's not the point of replacing intelligence. It's really, connecting that together. It's, I think, what we call augmented intelligence, but it's really connecting that together.
Absolutely. I feel like there's so much baggage to the term, artificial intelligence. But you're right. It's caught on so much that I don't think it's something we can really dissociate from. But at the same time, it's something that we should be actively working towards dispelling misconceptions about. And I feel like, AI sort of fits into that uncanny valley of intelligence where consciously you're right, we know what we're looking for. Consciously we can determine that Watson playing Jeopardy isn't really intelligent. Deep Blue isn't really intelligent. But then subconsciously our minds are like, that's intelligent, right? And that disconnect between your system 1 and your system 2 telling you two different things, confuses you to the point where you usually err to the side of system 1 and you're like, hey, that's intelligent. And there's a lot more nuance to that, but I feel like, yeah, you're right, there is a lot of baggage to that term. And I sort of want to extend upon what we just talked about right now and talk about the future of approaches to AI that can help us continue to mimic more and more tasks that, traditionally we continue to associate with human intelligence, even though that's not necessarily the case. And of course, even though we're doing them in completely different ways than we would organically. And so, artificial intelligence technologies evolved so much in even just the past couple of years. It's unrecognizable from what it was like 5 years ago. And, we've seen this huge sort of shift from different kinds of AI, right? We've seen the purely symbolic approaches of techniques like Deep Blue. We've seen like the connectionist approaches, the neural approaches to artificial intelligence. And we've even seen very large scale connectionist approaches, right? So again, OpenAI GPT-3, for example, we're getting into the trillions of parameters now, and we are starting to see it generalized to quite a few different tasks, which I will say is also something that, there's all sorts of misconceptions about, but that's a different topic. Now, though, I feel like we are slowly hitting those diminishing returns of scaling up models to trillions and quadrillions of parameters because, we don't want a single model that's good at everything, right? We want models that are really good at what they're supposed to do to enable those special experiences. And one thing that, for example, John Cohn and I were talking about a couple episodes ago, John Cohn's an IBM fellow, is neurosymbolic reasoning. And I know that, IBM Research does some stuff around the world of neurosymbolic reasoning. So do you think that is the next big thing in AI, and what's it going to enable us to do?
So Tanmay, let me chime in. I think the way I phrase neurosymbolic is it's almost an inevitability that the next sort of advances in AI capabilities are going to be coming by melding these two philosophies. Right? The philosophy of, so let's peel back a little bit to understand what the neural and symbolic. The symbolic AI, which is how AI originally began, is the philosophy of representing knowledge, capturing knowledge, writing down rules of inference, right? And that was sort of the classical way. And that's very powerful. And by the way, that's how we as human beings learn. We became this smart by allowing us to codify the world into symbols, give rules, and whether those symbols are like the symbols we use to communicate, like Dutch and Spanish and French and English, or the symbols we use to describe mathematics and physics. We did create languages and symbols, and we know how to reason with them. So that's powerful, we know. But then in the last, I don't know, 10 years, 15 years, as data became dramatically larger and we were able to bring a lot of compute, like as you said, the neural approaches showed dramatic promise, especially when you knew what task you were going after and could be smart about training model. But the next is going to be ML. And I think the answer is it's not as if neurosymbolic is this one thing. It's going to be different ways to bring neural and symbolic techniques together. You might cascade them together, saying, I have an overall task, and for step one of the task, I'm going to take a neural approach. Step two, I'm going to take a symbolic approach. That's one way. The other is I'm going to take a overall a neural approach, but I'm going to introduce symbolic reasoning in the way I construct it. Or I'm going to take a symbolic approach, but the rules that drive the symbolic reason are going to be learned from data. So there are going to be many ways you're going to combine. And I think what we're going to see is exciting advances driven by people being creative in how they bring these two disciplines together. And let me just give one example because I think it's useful for the audience. In collaboration with our researchers in MIT and IBM, there's this task called visual question answer, which essentially is a task where you take images containing simple pictures of blocks and shapes and spheres, right? Things you might give to a 4-year-old kid or a 5-year-old kid and ask them questions, like simple logical questions, like how many blocks are to the left of the largest sphere, pink sphere, something like that. Then you could answer that. Mm-hmm. And we know, and they demonstrated, that a purely neural approach that's fantastic at image recognition can easily spot every block, every color, every shape, cannot deal with logic. If you just take a purely logical approach, it can answer the logical question, but isn't great at the raw image recognition. So you got to stitch it together to eventually solve the task. That's just one example, but there could be many such.
And I think to add to that, so much of work has been done. I could say literally over more than a century on logic, starting with fundamental work on Boolean reasoning and moving on. In fact, AI was started with that particular aspect with Boolean reasoning, and there are some fundamental problems in computer science that actually capture the essence of that. Ignoring that very rich body of work, which is about logical reasoning and logical inference, is downright, I would say, just ignorance in terms of how these two techniques can be combined. And I do believe, there are, each camp may have entrenched, but there is certainly, you could continue to push the boundaries on neural, but it is, again, I'm going to go back to resources. At what expense are you doing this? And yes, those resources will continue to grow. There are 175 billion parameters on GPT-3 versus, you could go to trillion and you can go to 5 trillion. What expense are you doing it? And it's, in my mind, it's about efficiency. And that actually is one aspect in addition to adaptability, which defines intelligence. How efficiently we make those decisions and how efficiently adaptable we are as well. And to me, it will require combination of these techniques and many others. We may not have seen that yet, by the way, as well. So it's not that world will be limited to only these two. Our ingenuity is almost unlimited, I would say. And techniques that we haven't learned about yet that will get combined in there as well.
Mm-hmm. So there's a lot more to come, and you're right. Neurosymbolic reasoning isn't just one thing, right? It's per use case. It's really taking our old techniques that have worked well for so many years, and our new ones, and saying how can we use them both in order to power a certain use case. And we're gonna start to see more and more use cases that require this, right? As we start to apply machine learning technology to more and more use cases, more and more complex use cases, we're going to start to see those limits of just simply neural reasoning, and it'll be interesting to see how exactly symbolic reasoning ties into that. But that also brings me to what you mentioned, Ruchir, around resources, and that is that we are seeing ginormous models today, right? We are seeing huger models than we've ever seen before, and we have started to have to run these on like phones and tablets and even low power devices. We'll get to edge computing in a bit, but for now I want to talk about actually training and getting models to work in the first place. Do you think there's a place, or how important do you think the place is for example, ASICs, right? Application-specific circuits just for artificial intelligence and machine learning technology. What is the state of the hardware today, and where do you think we're going to see it going in the future?
I think excellent question, and in fact, it has AI, interestingly, has given rise to some kind of a renaissance in hardware area and computer architecture, or sort of hardware architecture as well, because of such an interesting use case that came about. And it's absolutely goes without saying that you are gonna start seeing architectures which are beyond, actually. We started with stumbled upon GPUs, let's say it this way.
Yeah.
They were great for doing matrix manipulations. Hey, this could be very good for linear algebra, and I have a classic problem for it. Okay, that's great. But then we figured out, hey, you could do that task because it is statistical in a lower precision, actually. I don't need this 64-bit mathematics actually to do this from a computer architecture point of view. I could do this with 8-bit and I could reach kind of same conclusions as well because the answers are statistical. I'm not looking for a bank balance to eighths of decimal place. Actually, I'm looking for what should I wear if I'm going out today. I'm all looking for is it like in 90s or is it like in 60s, actually. So the next progression to this is beyond the traditional computing architectures. We've been stuck with von Neumann computing and memory and compute working together in a traditional way for a long time. And I believe the next progression to this is analog, which really is a very interesting way of, again, I don't think we have all the time today. I and several others have directly written papers on it as well, regarding how does the world of analog, because the world around us is continuous. Signals are not discrete, they are continuous. How do we deal with actually that and memory together to be able to give rise to a new paradigm of computing? And sort of as we move forward, I think the word around, in some use cases, around how we combine quantum into this as well. Quantum and AI combined together, again, this will not be generic, because in all these architectures, I think, as IBM has called it, it's really bit neurons and qubits combined together. And it'll be about bits in the traditional world. It'll be about neurons and mapping of those neurons into interesting architectures with analog. And then the third aspect of this is quantum. And all of these systems working together will be the hardware substrate of how we realize actually these techniques and algorithms that come together to realize what we call AI. A misnomer it might be, but what we call AI.
Agreed. I think that's the reality, and there's a lot of innovation to be done because, as Ruchir said, you sort of landed upon GPU not by intent. It was there, and it became a perfect fit. But now that you know that this workload is the workload of the future, and it has its characteristics, you are going to rethink computer architecture in the context of what we know these workloads want to do. And quantum is interesting because it's going to throw at you a completely different way of having to design algorithms, right? So again, people have to remember that the input and output to a quantum code is still n bits going in, n bits going out. What's interesting is that inside you have an exponentially larger compute space than you would have with a traditional compute. So it's all going to be the smartness in how you leverage that compute space. So algorithms that can exploit that compute space effectively are going to shine. And then you're going to be in the business of, okay, I have a task to do. Should I do it in the GPU world? Should I do it with a reduced precision code? Should I do it with analog computing? Should I move it into a quantum piece and run a kernel in quantum? And then what's going to stitch everything together, right? So that's why I think we believe that these are these overlapping Venn diagrams. One doesn't subsume the other. So it's all going to be about how you stitch a thread through that and use the right thing for the right thing. And that's going to be fascinating.
And I feel like we're already actually starting to see that kind of innovation happen. I mean, first of all, as you mentioned, there's this brand new hardware substrate, really, and lots of companies are starting to adapt to this, right? So, for example, Google has their TPUs, right? IBM Research, I know, is working on analog processors, as you mentioned, which is really fascinating stuff. I personally love dealing with the world of the internals of compute and how it works. So seeing analog chips for AI is something that I'm fascinated by. And another good example is the neural engine on the iPhone, right? And like for example, Face ID. You would think that facial recognition would just be facial recognition, but just for facial recognition to exist like it does on an iPhone on a phone, you've got to have an entire dedicated neural processing unit just to handle it. And then, there's the Core ML APIs, and as you mentioned, Sriram, being able to decide where do certain components of the model go, there's a dedicated chip on the phone, not just for the neural engine, but also to determine where parts of the models need to go. Do we want to run it on CPU or GPU or the neural engine? What's the system load? All these different things taken into account to stitch it all together into a single cohesive experience. So you're right. This innovation we're already starting to see, and this is just the beginning, right? We're going to be taking this from the analog chips that we're seeing in research labs to more complex stuff on phone and vice versa. But as the hardware continues to get more complex, we're also going to have to see innovation on the software front. Of course, right? We can't just have innovation on one front. It's going to have to be innovation on all fronts. And software is something that I think has been a challenge for AI for a very long time, right? I mean, when the sort of demand for machine learning or complex machine learning started to rise, there was this sort of power vacuum in the programming language space, at least I believe, and Python sort of was the easiest language to fill that gap. Even if it wasn't the best language to fill the gap with, it was the easiest to fill it with, it is what I would say, which has kind of become more baggage on the world of AI. Now we have all this extra inefficiency because we've got millions of lines of code in Python that nobody wants to port. And from a software engineer's perspective, looking at the fact that everybody's using Python for AI is kind of painful, right? It's seeing that things are band-aided on to solve so many problems. And that's why, because this demand exists, there are new languages like Julia or like Swift for TensorFlow that came up out of the idea of, hey, what if we could build a programming language specifically for scientific computing? What if we could make it so that differentiation is built into the programming language? What if we could make it so that we could extract TensorFlow graphs without having to write them, right? Immutable state and all that stuff. So what are your thoughts on the world of, first of all, how software engineering ties in with machine learning? And after that, we'll get into how machine learning helps software engineering. But first of all, what are your thoughts on the way that software engineering and programming tie in with the world of machine learning, right? Like, for example, and one more thing that I want to say, do compilers, or is machine learning important enough to deserve first-class support in compilers, like Swift has done or like Julia has done? What are your thoughts on that?
I would say I think you raised two very important aspects. I mean, one is actually, interestingly, if you go back in the history of computing, some of these languages evolved at the time of symbolic AI. There were languages that were specifically built for it, and I think we are at a point where, yeah, Python was there at the time of the most recent resurgence of AI. But academia and industrial research labs have started looking into programming models. So that's one aspect of newer programming modeling paradigms for representing the kind of techniques that we are actually starting to evolve for AI. That's one aspect. The other aspect is the other way, which is, can AI and machine learning help software engineering? There are literally millions of software developers around the world, and just the sheer task of reviewing the code, just like we have almost think of it this way. AI, the most recent renaissance of AI started with human language. Okay, well, understanding human language, generating human language, chatbots, assistants, speech to text. This is sort of the modalities around us. Now, a good question is, could AI understand machine language? Now, it may appear very simple on the surface, interestingly, because, hey, this is kind of very structured, should be a no-brainer. But interestingly, human language has in the absence of a better word, I would say, a limited dictionary. It is actually defined in certain ways. Symbols in machine language can be almost infinite, and it becomes hard to actually deal with sometimes. So it is important for us to keep in mind that the research area of how AI intersects with software engineering, both from the point of view of newer programming model paradigms in this new world of neurosymbolic techniques, as well as the word of how AI intersects software engineering to help software developers with the task of, for example, understanding. So, how do you understand code and code with the embeddings? And when we say code, everything around us is becoming software. Infrastructure is software defined. Your phone is software defined as well, by the way. Everything you do, you touch and feel is going through a software through which you are touching that hardware, by the way. And because everything is becoming software defined, when we say code, it is not just source code for us. It is configuration files, it is logs, how machine communicate with each other, and it has a very wide ramifications in terms of what does software mean, and to be able to understand code, to be able to review code. One of the biggest part of software development process is code review for automated recommendations, performance, vulnerabilities, bug detection. All of us who write code on a regular basis would say, kind of to me 3 days to get the damn bug out if I'm lucky, actually, and not banging my head. So can AI help us in that? Getting the right piece of code. Interestingly, the way we write code right these days is no, it's almost like, think of it as I go on the net and I type in my query. I go to Quera, I go to Stack Overflow. I found this answer. I take it, I modify it. Finding the right pieces actually for me to be able to generate the right pieces of code. And again, the last one being test and verify. There is a wide gamut of capabilities that AI need to bring together, from code understanding to code review to code retrieve and generate and test and verify, with applications built on top of it, which are going to fundamentally change the game for software development and engineering, including programming models for AI. And I think I am, and I know Sriram is also, very excited about how this is going to come together. It's one of the most exciting areas as we move forward as well. Sriram?
I agree. The way I think about it is like, I think AI and software are going to become indistinguishable. Every piece of software is going to have AI in it, and you're going to experience AI, and you experience everything through software. And when what you in fact see happening is the area where generation of software, right? Ruchir talked about assisting a human being in producing software, in the process of software. But the area which has actually made the most progress in automated generation of software is actually data science itself. The amount of progress in auto ML and auto AI is basically the AI guy is saying, well, it's too painful to sit and write up the model in Python. I know what the model is doing. It's searching through the space, picking the right parameter. Let's automate that. So I do believe, and it goes back to something we said before, Tanmay, that it's hard enough to write program against just bits and get them right and get them debugged. Imagine writing a program that is now, line by line deciding what to go to quantum, what to go to bit, what to go to analog. You're not going to do that as a human being line by line.
Yeah.
You're going to have AI help you author a lot of software. But it's like these degrees, right? So, but then somebody has to write that AI. So it's not as if developers are going to go away. You're going to move up the abstraction layer to produce the AI that's going to help you write the software. Because no human being is going to sit and stitch all this together line by line.
And just to add to that, Tanmay, I have actually a precedence on this. I remember actually writing code for what the area which is known as software hardware co-design, which is the substrate we used to have was a GPU, FPGA, and CPU. Okay. And we were saying, hey, I'm writing a program. Part of it could go to an FPGA, part of it will go to a GPU, and part of it will go to a CPU. The substrate will change. There will be other elements that will come in. It will be analog. It will be quantum, as we were just discussing earlier. And it's just too painful to match, actually. And deciding what goes where and how it combines together to give rise to the task that I want to do, which becomes really critical. So, excellent point.
Absolutely, and I would say that we've already started to see actually a lot of innovation specifically for exactly what we've talked about, right? Having that substrate that changes and being able to target all these different platforms in order to enable more easy software engineering, and sort of that back end is something that people are already working on. A good example is MLIR, I think. Which is that new LLVM project, which there are multiple different forms for it that a lot of people say, but I think the official one is multi-level intermediate representation. So being able to have a single compiler infrastructure, even more abstracted away versus LLVM, as you mentioned, that's able to target essentially any different, programming or hardware platform, even if it's dedicated for a specific task like a TPU. So I can't wait to see the innovation from the compiler community, and of course AI is going to be helping them, right? We're going to start to see more AI machine learning infused into these compilers to make developers' jobs easier. So that's going to be it's going to be some fun times ahead of us, I would say, especially because I'm so passionate about compiler tech. So, this is the world of software engineering and AI. We've seen that they intersect in more ways than you would think, right? Because machine learning is such a broad technology and because it hits so many different areas. And now I want to transition over to another technology that's really popular and that I think intersects with AI in many different ways, and that is cloud. Right. So I had a talk a couple of months ago, actually last year, in Europe, and the title of the talk actually was AI and cloud, two sides of the same coin. Right. And what I meant by that is not like literally, AI and cloud are inseparable, but rather that, when you use them together, you can enable experiences that cannot be done with either one alone. What are your thoughts on that? How do you think cloud integrates with the world of AI, and what are we going to see in the future with that?
Let me start, and I think this is a very interesting topic for discussion. Um, I I think we firmly believe, not just we firmly believe democratization of AI occurs through the cloud because of exactly what we were discussing. The substrate is changing. The substrate will continue to change, by the way. And the techniques are evolving on a daily basis, I would say, because the innovation is so distributed across the world, from every continent you can think about, that the only way to democratize the massive innovation, I could almost argue unprecedented open innovation, is through the cloud. There is no other way, actually, to make it happen, because otherwise it will remain locked, actually, and we cannot make progress enough. So to me, it is about, if AI were to, prosper as it is, as it is destined almost, it needs to be through the cloud. There is no other way, because it allows access to anybody, anywhere, with an internet connection. Think of, just as a simple one, and I know Google Colab has become very popular. Just going through, drop down menu, GPU, CPU, TPU. That's all it takes, actually. And I don't need a TPU. I don't need a GPU, and it is available at my fingertips. And it's true with IBM Cloud. It's true with other clouds as well. So that's one aspect. The second aspect, it is also is that it's like what I call by the ounce, which is I can get things in very small, sort of from the point of view of resources. It's like $2 an hour. Hey, I could go launch a job, come back and pay $2, and I'm done. I don't need an infrastructure. Anybody, any of us, and many of us, and your audience as well are listening. Setting things up is painful, actually, and getting all the right libraries, getting all the right versions, it's managed for you. And the experience is phenomenally simple. So it's about AI everywhere. It is about democratizing AI, and it's about keeping with the fast pace of innovation in compiler technologies, in hardware technologies, in algorithmic technologies is critical. And the only way out for that innovation is through the cloud. And I hope the audience will agree with this. I think we feel very strongly about it. It's like almost goes without saying. That's the way forward. Sriram?
The other dimension to that is obviously you wouldn't be able to build and run and manage these big cloud infrastructures without AI. So there is that symbiotic relationship, right? So the cloud is the platform through which you consume the latest AI innovation, hides the complexity so that developers and open communities can innovate. But the people or the organization, the entities running those massive cloud infrastructures couldn't run them if they didn't have AI helping them manage, troubleshoot, monitor, run, residency. So there is a strong symbiotic relationship between AI being used to automate and run cloud operations and the cloud being the consumption for AI. And I think that pattern is going to continue to remain.
Excellent
The
point.
only other thing I would add is that, where we are in that journey, especially as enterprises embrace this, traditional enterprises that were existed and operated the business before the emerging world of AI are navigating this transition, because remember, AI doesn't happen without data. And so you got to now move AI to where the data is. Data is also going to be moved, and your AI is going to move along with it. So it's one of those interesting landscape in which your substrate is evolving, both in terms of the actual underlying hardware getting innovating, and the data getting moved. Companies making decisions on what I'm going to store where, and then you got to bring AI where that data is. Because even now, I agree, GPT-3 models are massive, but on average, data has more gravity than models.
Yes.
So if you have a massive data sitting somewhere, you got to take the model there. You can't afford to bring all the data over to a place where the models are. So that decision is starting to be made. And there's a lot of space for innovation, a lot of space for innovation.
Absolutely. You are completely right. And I really agree with your assessment of, the data has more gravity, right? And fundamentally, we want AI, we want machine learning to be where the data is. And, if that's on the edge, then we want, quite literally, machine learning models to be fine-tuned on devices and sent back up, with that federated learning that so many companies are doing now. Even down to like the emoji prediction on Apple keyboards, done with federated learning. And so there's so many different things that are being done here. And I feel like one common thread among all these fields is that AI has a symbiotic relationship with so many different fields, right? With cloud, it's that AI is helping with management and actually keeping the cloud infrastructure up, but at the same time, the cloud infrastructure is democratizing access to compute power so that we can continue to have this, I would say, yeah, you're right, unprecedented open innovation within AI, right? I don't think any other field has seen innovation as open as we have in AI, and I think that's important because if it weren't, we wouldn't be where we are today. Imagine if like Microsoft had kept ResNet proprietary to themselves, or if IBM had, completely kept all the technology behind Project Debater, proprietary to research. It wouldn't. Things wouldn't scale at the exponential scale they are today, right? So I feel like that is definitely important to get into. And speaking of data and how data has that gravity, I now want to talk a little bit about blockchain. Now, actually, a couple episodes ago, I was talking to Andy Martin, who's the worldwide blockchain value design lead at IBM, and also Tim Duncan, the product growth lead at BottleRocket. And during that discussion, of course, we delved into the world of blockchain, and there were two key things that Andy said. One of them was that, of course, blockchain is a governance technology, but also that blockchain is really about, if your data has value to you, then you're going to want to use a blockchain to control access to it, or to be able to store that data or understand that data. And now I want to see if blockchain and data have this sort of inseparable link, and if AI and data have this inseparable link, then there's a common thread there. And I want to see, how does blockchain tie in with AI, and what are some examples of what we can do with the two together that we couldn't do previously, or we couldn't do with either one of the technologies?
Great question, Tanmay, and interesting that I've had a chance to dig deep into blockchain for a while, and then while I'm doing more AI right now. But as you know, we've had this strong investment in IBM, and the insight was really what you said. And I believe the answer for AI blockchain is not very different from the answer we gave for AI and cloud, and they have a symbiotic relationship. So a couple of directions. One is, we talked about trust. Let's go back to where we began the conversation. We said one of the elements of trust is the provenance and the lineage of how that model came to be, where it was trained, who trained it, what was done to it. And one of the exemplar use cases of blockchain is, supply chain tracking in the physical world. Now, think of the supply chain that goes behind the model. Today, that supply chain is very much localized, sitting inside one organization. I take my data, I employ my data scientist, I do this labeling, I'm going to produce a model. But as soon as that supply chain charts to get distributed, my data comes from you. I'm going to have this third party do labeling for me. Some other shop is going to go build the model for me. I'm going to deploy the model. Right away, you have this analogy between the supply chain that powers an AI model, looks very much like the physical supply chains that run the world economy. So the same analogy of, okay, if blockchain is going to transform global physical supply chains, you're going to have that same. You're going to need blockchain in the world of the future where the AI models and the data are not all run by one organization, they're going to stitch across. So there is a strong relationship between blockchain as a substrate for helping you track and have trust in your AI and the data that the AI was. Other way around is as organizations come together on the blockchain, whether they are doing it for banking transactions, whether they're doing it for supply chain transactions, whether they're doing it for other things, data is going to land on blockchain, right? Now, this is data that initially starts off with, I have my data, I put it on the blockchain to share it with you. Somebody else has the data, puts on the blockchain, shares it with you. But eventually there is data in there that is not present in any one organization. So when you want to do insights on that data, the only place where you can get insights that cut across the data owned by organizations is to do that AI on the blockchain. So it's going to be fascinating to see how you do AI on a blockchain while respecting the trust and privacy and confidentiality guarantees that get organizations to come together on the blockchain. You still have to respect them, but still provide insights that are valuable. So AI on blockchain, which will touch, how do you do AI with multi-party computation? How do you do AI on encrypted data? How do you do AI while confirming that I respect privacy and confidentiality guarantees? That's going to be fascinating as well. So AI on blockchain and then blockchain enabling trusted AI are sort of the way I see these two relations.
Yeah, I think one aspect that Sriram just touched on, and I don't think we have enough time to actually go through this, is very interesting aspects on computations on encrypted data, which will become critical as we move forward as well, because there are some very compelling scenarios where you don't want to decrypt your data. And on homomorphic encryption and how do you do computations on that has very interesting ramifications on how we move forward with blockchain and other technologies as well.
I feel like we're really seeing that common thread of AI having a symbiotic relationship with so many different technologies. And you're right, blockchain is a technology fundamentally of trust. And we can use it to enable trust in data, which enables us to trust AI, right? It's sort of one thing leads to another, and being able to verify that, I think you put it perfectly, supply chain of data that you're feeding into your models is absolutely critical. And now, finally, I want to get to one more field before we actually start answering some questions from the audience. We've got lots of really interesting questions from the audience, and that is about the world of edge computing. So, as I mentioned, we've seen so many really interesting applications, putting compute on your phone, right, for neural networks and all this complex stuff. And these models are getting larger, they're getting more complex, they're getting more capable day by day. And so we've already touched upon, there's definitely a future for custom silicon or custom, I'm not even sure what we would call it because we're having completely different compute architectures in the future, right? But we have space for custom circuits and custom compute architectures in like data centers and clouds for the world of AI. But in terms of at the edge, what do you think the future is for custom compute at the edge? And how do you think that's going to evolve?
Let's talk about, what the definition of edge can vary a lot. Interestingly, the almost by default, people think of edge as when somebody is thinking of edge, it's this actually, which is to me, if you are thinking of a graph, a tree actually in a graph representation, and edge is where you are at actually. To me, that is the edge because my abstraction level is at that boundary actually. And for example, for a consumer, an edge is this because that's how they're experiencing AI. To a telecom provider or to a telco, an edge is a cell phone tower actually. Yeah. And to someone else in manufacturing, edge is a machine that they're dealing with. So to me, the definition of edge really varies a lot, and we should. That's why I wanted to start with that definition, which is, edge varies according to the consumer, because to them, edge is wherever they are sitting. Actually, that's the edge of the word as far as they are concerned. Now, interestingly, the aspect ratio and kind of compute that will be needed on the edge, I would say to a large extent, and this links us to the discussion we were having earlier on cloud and AI, which is, yes, they are the two sides of the same coin, but to a large extent, obviously federated learning and other techniques play in, but a lot of training potentially will be done in the cloud. The models will be deployed on the edge actually, but sort of heavy compute where the base models, these really large complex base models, will be trained in the cloud, deployed on the edge, and they will live on the edge, and they will get refined on the edge as well, whereby the continuous stream of data, because data has a gravity, not just it has a gravity, many times it has affinity. For could be regulatory reasons, could be many different reasons where data cannot move. Even if it wasn't heavy, it cannot move because of different reasons, and it has a affinity, whether it is because of gravity or because of other ancillary reasons. It needs to exist in there. And to me, the inference of AI will be pretty much more and more moved towards the edge. It'll be less and less in the cloud because that gives rise to this latency of back and forth. Those models will move to the edge. As models become more complex, the compute on the edge will become more efficient as well. And this is where we were discussing earlier the innovations in hardware.
Yeah.
Whether it is the innovations in circuits and hardware and compiler technologies, all of that will bring together this forces that will move the AI models for inferencing towards the edge, and their refinement as well, their life cycle will reside towards the edge as well. And in some use cases, you will have these sort of the edge nodes, if I may, will work in concert to evolve that model as well, what we now call federated learning, and those techniques will evolve more. So I think to a large extent, I would say, lot of training, heavy duty training in the cloud, which is where the two sides of the same coin, cloud and AI together. And with the innovations going forward, will move the inference more and more towards the edge, with software technologies making that happen, and innovations in hardware coming together. It's just mind-boggling even where we are today. Looking at innovations in I play with actually a lot of these we look at Coral board or developer boards from Coral or other boards that we are looking at from a development point of view. What can 2 watts do? It can do a lot actually, and the aspect ratio of a half the size of a credit card. It's just, I think innovations in those technologies will be just, I'm looking forward to what it unleashes in terms of, again, it will have a very wide impact on the developer ecosystem as well. So, Sriram?
I agree. I think to me, the interesting aspect is how do we make this again simple for the developers? If I'm building edge AI applications, I have to think about every element of where I do training, when the model gets updated, who I have to be. I think there's going to be interesting platforms to be built, where as a developer, I can think about the experience that I want to provide and the intelligence that I want to infuse. And then a lot of the plumbing around when to retrain a model, when to go back, when to get it updated, adapting are baked in. So you really want some of that AI intelligence sitting in the platform so that the developers can be as productive. And that's the same pattern we have seen, right? You got to move up the chain and get the developers to focus on the innovation as opposed to dealing with the plumbing. So I think a new SDKs, new platforms that enable you to develop and deploy and manage AI models and the data that goes with them are going to really drive developer productivity.
And Tanmay, I think just to, Sriram mentioned this earlier on, automation of AI actually is intertwined with the edge models as well, because the edge can vary a lot. You don't want to, this is about experience that Sriram was just mentioning. Automation has a key role to play in this, which is it should be almost seamless actually. I just say, I want to deploy it on this platform and done actually.
Yeah.
I don't need 5 days to just try to tune.
Otherwise, you can't scale. If edge is going to be 1 million devices, each having their own little localized tuned version of some massive model, I'm not going to be managing 1 million plus one model myself. It's just not going to happen.
Yeah, that's not going to work. And you're right. Edge is different for everybody, right? For a consumer, this happens to be our edge, right? Your headphones could be your edge if you're using AI-powered noise cancellation. Your webcam could be your edge if you're using, AI-powered autofocus or whatever. But for everybody, edge is different, right? For a manufacturer, edge is in their factories, the machines, right? And being able to scale edge to the different needs that different people have, and being able to customize edge to those different machines and to those different use cases, to those different nodes, that's something that we need AI to help us with as well. And so we're seeing, that sort of cross-linking of AI enabling us to build better AI and to scale better edge computing. And it's really fun stuff, is what I would say. And so now, what I would love to do is get into answering some questions from the audience. We've already got a lot of questions, and I want to start off with a question from Omer. He's asking, how does IBM Research pick the projects that they want to work on?
Okay, great question. So, like everything else, we have sort of dual goals in IBM Research, right? So, the one goal is obviously advanced AI from just a science and technology perspective. And this is where we participate in the open community, publish in conferences, interact with academia, and that. The other part, of course, is driving work that impacts IBM's business strategy, our products, our offerings, software, services offerings, right? So, the way IBM Research chooses projects is really at the intersection of both of these things, and pick a portfolio of projects that balance between pushing the boundary on AI and working on projects that take those advances and make them relevant. So as an example, I'll take something like, let's go to Project Debater NLP. We have a strong investment in natural language processing. Why? For two reasons. NLP is going through a dramatic revolution with new models and new techniques. At the same time, I can't just take that innovation and say, here you go, customer, use this now in your enterprise. Like, how many customers are going to be able to manage and run and can afford to invest in just massive models being used for NLP? So we got to take those innovations and then deal with the reality of where text lives in an enterprise, adapt it, make it customizable, easy for companies to adapt and deploy NLP. So a lot of the work in Watson Assistant and Ruchir should shine through it because he actually lived that journey. He was responsible for taking the innovation from research and making it consumable for developers across the world to use Watson Assistant to deploy conversation systems. And that now is at the intersection, it meets both needs. There'll be some other projects that push the boundary. Our work in fundamentally advancing neurosymbolic AI, we don't begin asking, okay, how is it going to drive $10 of revenue? But we know that if we advance neurosymbolic AI in the open, it will drive innovation in AI, go through our products. It's a portfolio statement, and we will constantly look at, are we having the right balance between these two objectives? And it's never static. That's the one thing I can tell you. It's never static. It changes. It continues to fine tune and adapt to the world around us and the way IBM decides to go to market.
I think just to add to that, and as Sriram said, many of us have experienced both sides of this in terms of how we pick projects and how we actually move those projects as well to really benefit consumers and our clients and enterprises as well. Being on the other side as CTO of Chief Architect of Watson, to me, the new model of innovations in research is closely tied with this flywheel of how we bring them to production as well. From, you start with research ideation, research incubation, what we call joint product offering vision. Gone are the days when research will just sit in a kind of a ivory tower and will sort of dream up ideas, which we do, by the way. But it's also very tied into how we execute those ideas as well. Again, this goes back to the agility, because things are moving so fast in this AI space that until we were tied in at the hip with some of our advanced development partners, from, as I said, from joint offering vision to joint leadership and what we call a joint squad model now, regarding, we really are partners in how we are developing technology. So research is no longer just innovating on algorithms, it's also innovating on how these algorithms will be implemented, because you really understand deep down what goes into kind of building those algorithms and what is affinity of theirs with respect to hardware and what kind of compiler technologies might be needed for it. And then again, what we call beta deliveries, going to working with the clients, leading edge clients on it, to making sure where the gaps might be and really launching that product. including, we shouldn't minimize explaining the technology to a general user. All of this is research and production closely tied together in terms of us thinking about ideas and incubating those ideas and really bringing them into production. And to me, that, we talk about agility in the cloud. This is agility of an innovation model, which actually really brings ideas from pretty much from research into through the production into the enterprises on a phenomenal speed of execution basis. I can certainly tell you one of the products we were working on recently. This is Sriram mentioned this earlier on, AI for cloud, known as Watson AI Ops. This is like you're talking about months actually, not years actually. You have an idea, you're taking that to the market in a year, and you are reacting to the forces of the market pretty much on a weekly and a monthly basis.
Wow, it's really interesting to see just how much research has changed in the past couple of years, right? So seeing how the innovation now lies on two fronts, right? As you mentioned, Ruchir, it's first of all being able to research new techniques and new algorithms, but also at the same time being able to know how are we going to take whatever it is that we're building and actually bring it into people's hands. How are we going to make it so that we leverage that innovation somewhere, and it's not just like sitting on Git. How are we actually using it, right? So that's I think the important part. And Sriram, you mentioned that IBM's investing a lot in natural language processing. Really quickly, I'm going to make a bit of a side note because I am personally incredibly passionate about the world of natural language. I think it's the one place where AI hasn't really fully hit its mark yet, right? We've done a lot in vision, we've done a lot in audio. I think it's now time for a lot of innovation in natural language. And so I know that one of the more recent projects that IBM Research has taken on in terms of like a grand challenge project was the IBM Project Debater. Can you tell me more about Project Debater? Why it's important, what it's about. I know a little while ago we were discussing whether or not social media is harmful, and who knows, maybe Project Debater can help us decide.
Agreed. No, it's fascinating. And look, the way projects like Project Debater happen is when we kick it off, we don't kick it off as asking a business question. It's a grand challenge. Can we get a machine to debate? And the intent is when you try and solve the grand challenge, you by necessity have to push the boundary of the art of possibility. And then we will harvest that innovation. So today we are in the phase where we did the grand demonstration of Project Debater. We continue to evolve that demonstration. I'm sure the audience has seen, or you can share with the audience some of the videos of the actual live debates and things that Project Debater has participated in. But what's equally important is now harvesting that innovation into our products and offerings. So some of the work that we had to do in deeper sentiment analysis, better classification technology, better customization of classification technology, that's making its way and will then benefit a broader spectrum of natural language APIs and offerings from IBM. Whether you're consuming our conversation systems offering or our content analysis offerings or just the raw natural language processing APIs. So that model is a model that says some of these grand challenges are great because it allows you to take a bunch of really smart researchers and go make that happen. And along the way, they will solve a lot of interesting problems. And then it doesn't matter really whether the act of debating itself is a product or not. Maybe not, it doesn't matter. But the NLP advances then become valuable to make progress. And it also is the place where then we realize, well, to take a particular technique that was used for debater and make it usable enough for the enterprise. That often turns out to be non-trivial, and we learn a lot along the way. I'll give you one example. You talked about, we talk about the fact that a lot of the content inside enterprises is not sitting in the public domain. It's sitting in PDF documents. It's sitting in large, complex contracts. No public-facing NLP benchmark that a scientific or technical community starts with PDF documents.
Yeah.
They say, I have a lot of emails. I have a lot of conversation systems. Here is a set of Wikipedia. Go solve the NLP problem. Great, fantastic. We'll go solve the NLP problem. Now get that problem to work in an enterprise while the text is sitting inside a PDF document. You got to do a whole bunch of other innovation. And so that's why I go back to what I said. In IBM Research, we have this luxury of looking at both sides, playing in the open game, also seeing the reality of what our enterprises want, and then drawing the bridge. And that's what we're doing in NLP quite a bit right now. NLP also, by the way, is our sort of cornerstone for advancing neurosymbolic AI. As you said, we have done a lot in some of the other modalities. I believe, this is just me, one of the reasons why I believe NLP continues to stress their AI more than some of the other modalities is when it comes to human language, we as humans truly adopted neurosymbolic reason in our heads, and we create language through our internal neurosymbolic AI.
Yeah.
So if you want to work with human language, you better advance neurosymbolic AI. And so it's a great touchstone for are we making progress in neurosymbolic.
I absolutely agree because natural language processing is fundamentally about understanding ideas, being able to create mathematical representations of, even abstract ideas or concepts that we synthesize in natural language, right? And that's, I would say, impossible to do to the level that we want to be able to do it without something like a neurosymbolic approach, right? No matter how much we try and scale OpenAI GPT-3 or, how many parameters we plop on top of it, if we really want to reach the levels that we've reached with our kind of intelligence, I think it is important. Now, of course, Project Debater is really fun. There's, of course, the Project Debater online demos that anybody can go and sort of Google Project Debater. You can take a look. But I actually generated a custom little debate narrative with Project Debater, and I gave it the debate motion. Social media is harmful, and this is specifically the con, so it's taking a look at why social media is not harmful. And I recorded that, and I fed it through Watson Text-to-Speech, so I've sent a link to that on all of the different live streams. So if you'd like to take a look at why Project Debater thinks social media is not harmful, feel free to go take a look at that. It's in the live chat, and I'm also going to put it in the description of the YouTube replay once that's up. If anybody has any requests of something they like to hear Project Debater speaking about, feel free to put it in the YouTube comments, and and I will try to get Project Debater to give you a narrative for that. But yeah, this is really interesting stuff, right? Natural language processing is fundamentally one of the most fascinating things that we can do with AI today because it's how we communicate, right? It's the cornerstone of how we as humans communicate, and we are social beings, so communication is important to us.
And Tanmay, I think just to interesting, it has interesting ramifications on what is language. Language is symbolic representations.
Yes.
There are, as Sriram mentioned earlier on, there are symbols in mathematics. There are symbols in chemistry. There are symbols everywhere. There are symbols in biology, by the way. We have captured our understanding of sciences in symbols. And I believe progress in natural language understanding and processing can be applied more broadly to symbolic, the way we have captured our world around us in symbols as well. So it has ramifications and implications on obviously natural language domain itself with the human language, but it has ramifications on a much broader field of science, from biology to chemistry to you name it, actually. As well. So it has quite fundamental ramifications. This is exactly what we at IBM are focused on as well, in terms of fundamental advances in natural language technology from the point of view of variety of modalities or way natural language can come together, from PDFs to you name it, but also the ramifications of that on broader symbolic capture that we have of the world around us, from chemicals to biology to everything else.
Wow, and I feel like you put it in a really nice way, because I've always been fascinated by how humans are the kinds of animals that we can take complex neural states, even imaginative ones that we've never physically interacted with before, and we can encode them into natural language in a way that other humans can decode them and suddenly have a similar representation of that idea or that concept in their head. That is such a powerful ability, and I think you put it in a great way. Language is a symbolic representation of our neural states, and so that it's fundamentally linked with the neural and the symbolic sort of reasoning there. So yeah, you're right. Natural language is that good sort of benchmark, or is that good jumping off point for all sorts of other symbolic reasoning tasks, combining that with the kind of modern AI technology that we have. Now, there is another question that I do want to ask. This one's really interesting, and this one's from Shiva on YouTube. She asks, what are the limits of AI, and where do you think AI will be in 30 years from now?
Wow. So can I just begin by saying, when any technologist today makes a prediction 30 years out, don't believe it.
I agree.
You have no clue what's going to happen 30 years out. So I can say something, Ruchir can say something, but I think this thing moves so fast that I think we're way beyond our human AI to predict 30 years out, to be honest. But look, I do believe that, I think we've already talked about neuro-symbolic AI. Will we get to what people are calling artificial general intelligence in 30 years? I doubt it. That's just cheap. I doubt it. I think what we will see increasingly is we will see all of these dimensions we talked about, whether it is trust, whether it is scale, whether it is how AI becomes infused, that we today talk about AI as it's a separate thing. We stopped talking about the internet as its separate thing. We used to talk about the internet as this thing that we used, 20, 30 years ago. People don't even use that word. They just say, go online. I connect. You assume implicit connectivity to a worldwide network of resources almost for granted. I think in 30 years, we'll get there with AI. So we'll stop asking the question, is this AI or not? But will that be general intelligence? I doubt very much. I think that is not. That's my view of where we'll be in 30 years.
So I would, first of all, totally agree with that any prediction is bound to be a failure by definition that far out. Having said that, let's go back to intelligence. A large part of that intelligence that doesn't get captured is empathy. What is who are humans? And to me, it is about complex combination of reasoning, logic. AI will become, I do believe, will very good at narrow tasks, even if they might be deep, by the way. Hey, taking a look at an X-ray report, I think it can become very good at a very narrow task. I almost think of it as nails in a board, actually. There's so many tasks which are narrow and deep. I do believe AI can become very good at it. It can be a outright failure at tasks that span so many of those. I'll give you the simplest of examples. I go to a restaurant and I want to have a good time and experience with a waiter. Man, it is hard to nail down with AI, actually, because that is a very, even if it might appear like a simple task, it is a very complex task because it involves emotions, it involves the way the waiter is interacting, the way the waiter comes back and asks you. It's that is much more complex. And to me, it is about it is not about whether we can just do certain tasks very well or not. It is about bringing a lot of these modalities together, and where I believe we will continue to lag sheer human ingenuity and intelligence for a long, long time to come. Not just because of this human brain takes, I said it earlier and I'll end with that, takes 20 watts and runs on sandwiches. Tell me a hardware when we have it which takes 20 watts and can do everything we can do. Just take 30 seconds and think about all the things we do, actually. From the point we, even when a child is born and is small, all the things that they can do, and forget about adults. We will continue to lag, and that's where I believe, it is combination. It's not a competition. It's what I'll call a co-opetition. Which is really us aiding each other and making progress as well.
I feel like a good way to put what you said, I mean, even just, you go to a restaurant, you want a good experience with the waiter, that seems like such a simple thing to do. You've got this limited scope of conversation. You can be talking about the menu, you can be talking about the products, you can be talking about the ingredients with them, you can be talking about allergens, whatever. But you would think that there would be a way to encapsulate all of that and understand in the context of a conversation enough. But the thing is, within human society, conversations have weak scope, right? Like, you could walk into a restaurant, sit down at a table, and the waiter can come up to you, and you could definitely talk about what it is that you want to eat and never leave the scope or the context of the restaurant. Or you could ask the waiter, what's the weather like outside, or what's the time, right? Or what's, you could do so many different things, because at the end of the day, it's just human interaction. Sure, it happens to be that based off of the context and the setting of where you are and what the waiter's doing, it happens to be that the scope is implied that you would be talking about the restaurant or the food or what you want to order. But that's not necessary. And when you can't do that, and when you have to put conscious effort into thinking, what can I say to this AI that it'll actually understand me, that is where that sort of unintuitive portion comes in. The day that we can have that general conversation, which I think that's much more than 30 years out, that's the day we're going to start to see artificial general intelligence. So it's good. We also covered Tassin's question on what do you think about artificial general intelligence. I don't personally think we're going to be seeing that anytime soon, but even if it is technologically possible, I don't think we're going to be seeing it anytime soon. Now, another really interesting question from Tassin actually is, should we continue to compare AI to human thinking, or should we categorize it as something different? Ruchir, I already think you touched quite a bit upon that, but is there anything else you want to add?
No, I think I touched quite a bit upon it. Good to hear Sriram's thoughts.
No, I think we will continue to draw inspiration from human thinking.
Yes.
I go back to what I said with birds and flying. I think we will draw inspiration. We will always shoot for a 20-watt sandwich eating sort of benchmark. I'm just going to use Richard. But we're going to use that, but solve this differently. And as long as what we create is useful for humanity, why not?
I couldn't agree more. I think it's about finding the use and helping human society, helping ourselves. It's not about, planes are very useful. Of course, they're very useful. Did we, as Sriram said, did we adapt the same mechanism of flapping? We tried it. It's not that we didn't try it, but we found a different mechanisms. And birds don't carry 500 people and trucks in their load as well, and we do actually. So it's a different ways of achieving it.
It's a different sort of purpose, and I feel like I really like Rob High's way of describing it, and that is that even if academically, right, it were scientifically, technologically, it were possible for us to spend the effort to work on something like artificial general intelligence, what exactly is the reason for us to do that, right? What's the business justification for artificial general intelligence, right? If we take a look at GPT-3, again, we're not saying this is AGI, but I'm just saying, if you've got a single machine learning model that has mediocre performance at a lot of different tasks, that's not nearly as useful for business as a single predictable model that you know is really, really good at sentiment classification or sentiment recognition, right? So I would say that, yeah, I don't completely see what that value of AGI particularly is, and I don't think we're going to get there anytime soon. Now, another question, and this one's actually around healthcare in specific, and Tassin's asking, can we do surgeries with AI instead of surgeons? So that's the key word, instead. I don't think we're going to be replacing surgeons, but what do you think?
I'll start, and in some ways, some of you may be aware, robotic surgery has been in existence for almost last decade. Intuitive surgical, prostate surgery in limited domains where the task could be narrower. Now, of course, it is guided by a surgeon. So it's not that, robot is doing surgery. Again, this is about augmented.
Yeah.
Precision may be better with something that can move literally, micrometers versus, your hands sometimes. But it is the sheer intuitive thinking and the adaptability of what a surgeon can do and what they observe at the time of surgery, and can the machine adapt with all the modalities that are coming into a surgeon's mind. That won't happen. Now, given a task, a very specific task, make an incision. Okay, that could be done. But what happens after that incision, and what you are seeing and what you need to react pretty much on a seconds basis where life and death decisions are made, I don't think that will happen actually. So to me, again, it'll be a combination of intelligence, robotics, and sheer human intelligence, which will make the healthcare field a lot better, and will scale it out as well. Actually, Shreya?
I agree. I think we're talking about, and there are lots of reasons too. Also, there will be societal and ethical reasons for human supervision that I don't think we're going to get comfortable getting it. I don't care statistically. You might tell me that machine is going to be 99.95% more accurate, and the average human makes 3% more mistakes. But there is something about the way we are constructed that we would like to see a human supervision in there. And it eventually comes to our own comfort that I think, at least I don't know when AGI will be, but in the near term, we're likely to trust that the human person will make the right judgment call when a tough decision is made. And so it will be augmented. The robot may do all of the actual physical activities, but there will be that human supervision that I think will be necessary for us to define it and be comfortable with it in the fabric of society.
It's almost like this, man. If I'm sick, And a physician comes to see me and says, Ruchir, you will be okay. Versus a robot comes and says, Ruchir, you will be okay. There is such a difference between the two. As Sriram said, it's like what we are constructed as humans, and this goes to empathy, actually. The point I had earlier on empathy, we are a long way away, actually, from the trust. Again, it goes to the trust as well. You were built with a model with the data. The world is evolving all the time. They say, yeah, I have this tested and verified with 99.3% accuracy. That may be true, actually. So
Yeah, you're right. There's something about that human interaction that for us as humans is really irreplaceable, right? It's something that you really need from an empathy standpoint, from an understanding standpoint, and I feel like another reason for that is because edge cases are something that humans can deal with that machines can't, right? It might come down to the general nature of our intelligence, but at the end of the day, if there's something new, if there's something unexpected, something that the AI wasn't trained to deal with, humans have that general reasoning capability to be able to say, you know what? Based off of my experience, we should be doing X. Whereas that AI is going to be like, which category does this fit in that I've been trained on, right? So again, that's just a very high level simplification, but that's the general idea, right? Being able to deal with edge cases, these sorts of things. Another question is, how can we detect emotions by just a simple conversation? Things like pain or loss or loneliness. Can we use AI to detect emotions, basically?
And I think, yeah, and you can to some extent. I mean, there are, look, what we express is a function of what emotions we are speaking. I think the challenge in a purely unimodal interaction is if all I have is text coming out through a conversation system, I think I'm limited. And that's true even for human beings. We really eventually judge emotion with a multimodal interaction. I see your voice, I hear your tone, I see what you're saying, the words you use, and all the other body language. Could we build an AI that is better at detecting emotion through multimodal? I think we can. I think we absolutely can. I mean, there are enough studies as this example of successful studies that have shown that by simply analyzing the words, you can get early signals of mental illnesses early on, especially psychiatry. So there are. So there is enough signal in there. And if we choose to go there, I think we can build AI that starts to do this. Again, I don't think it is about whether we can or we can't. It'll go back to, should we? What is the purpose? Is it going to assist? And I think it's the use case that is going to drive it.
Absolutely. Very interesting. And also another question. This is one that I'm particularly fascinated about. This is from LinkedIn. This is from Ajit. He's asking, how do you see the future of quantum computing in data transmission, computer network efficiency, and the internet? We're kind of straying away from the AI a little bit, but if you have any thoughts on this, that would be, I think, interesting to talk about.
So there is definitely, so quantum computing from a computational aspect and its implications to AI we talked about. We talked about the fact that you are going to need new algorithms to exploit the exponential compute capacity. On the communication side, there's been this other sort of almost parallel tack on quantum communication, which is looking at it more from an encryption confidentiality perspective. So, eavesdropping on quantum, exploiting the property of the fact that a quantum communication channel could give you unique capabilities when it comes to secure communication that goes beyond today's communication parameters. I have not seen personally, and this could be just not seen anything that melds the two together. So I think there's almost today progress in quantum communication, there's progress in quantum computing. Eventually we will bring it together, but at least I haven't seen anything that really brings it together. It almost seems like they are parallel fields and different research groups conducting.
Interestingly, I think if you go back to the field came together even earlier on with communication and computations together. Whether it is the theory that Shannon had or others, I do believe it will come together because they certainly are very intertwined. It's about generation of those bits to be able to ensure the encryption. The encryption theory itself is about eavesdropping. The whole theory, actually, the theory of probability around that is about eavesdropping as well. But there are few people in our history who have brought it together, whether it was Feynman or whether it was Shannon. who had the sheer intellect to bring these fields together. I do believe, I think as we move forward, this will fall in the areas of we haven't seen this yet, but it will come together actually, as Sriram said.
Very nice. All right, there are two more questions that I do want to ask you. Of course, if anybody else has questions, feel free to put them in the live stream chat. We will go ahead and answer them. This one's from Yomi. Yomi's asking, how do we incorporate risky technologies into the traditional curriculum to ensure the upcoming software engineers could learn applicable and in-demand skills?
Trying to think through. I would. So first of all, I would really say we talked about democratization of AI, and I do believe one thing that AI is doing, which hasn't been done earlier, is the sheer number of students across the world who have access to not just the lectures from some of the best teachers in the world, but also access to the compute and the access to the software infrastructure that is needed to make that democratization happen too. Now, I'm still trying to decipher risky technologies because to me, every technology has two aspects: risky, beneficial. Whether you take a simple hammer, you can use a hammer to bang someone, you can take a hammer to bang a nail actually. So every technology has two aspects to it, and I would like to think that we would focus more on the beneficial parts of the technologies. But having said that, the technology itself should also focus on mitigating the risky part of those technologies too. Interestingly, as we are seeing in social media, the discussion we started with right in the very beginning. So I think from the point of view of democratization, IBM has been investing in efforts. We have effort around what is known as PTech actually, which is really to be able to take high school students and have these 2 years in sort of internship programs and curricula that enables them and makes them ready for skills in the real world. I firmly believe the curriculum should evolve to a more, obviously a theory, but a more practical aspect as well. And I know there are schools that are evolving, whether it is Olin or others in Massachusetts, which are really melding the practical aspects and the theory together in terms of skills that need to come about. And Trira?
Yeah, so like I said, I don't know if the question was specifically about AI or beyond because risky technologies is very broad. But at least from an AI perspective, I think there is value in recognizing that it's at that intersection of different traditional disciplines. You can take it you can come at it from a statistics side, you can come at it from a data science, data mining side, you can come at it from a software side. So I think finding ways, even in today's curriculum, to expose whoever is in one of these streams to the fact that there is something interesting happening at the intersection. Okay, I understand the math behind, I'm a statistics guy, but how do people actually use my statistics to build a model? Okay, expose me to the software side. I'm coming from the software side. I hear this thing called AI. What statistics do I need to be able to actually understand what I'm doing? I think that is valuable. And many of the curriculums are already changing to adapt to that. And there are, of course, new dedicated data science curriculums that are starting from defining that intersection and giving you exposure to all of these things. So I think that is true. The only statement I would make to risky is, I think from the get-go, issues of trust, what the technology is good at, limits on the use of technology, I think this should be part of the education from the get-go. Trust and understanding technology can't be, I'll teach you all the power, but I will not teach you the negatives or the constraints, would be a bad idea. So making sure they are seeded in the curriculum from get-go means that everybody who comes out understands the pros and cons of the technology.
And I think
just having a hammer and not knowing what to use it, right? You got to know how to safely use it and when not to use it.
And also we will figure out as we move forward as well. You don't know everything in the beginning. Like take facial recognition as an example, by the way. The intent wasn't actually wrong per se, but as you move forward, you realize the ramifications it may have, and then stepping back. Actually, IBM took the lead in saying, okay, yes, we realize and we are gonna move out of that particular area in the context where it was having ramifications which wasn't intended as well. So absolutely, the risks of the technology have to be kept in mind right from the get go. But on the other hand, we don't have all the information from get go as well. So it's about that adaptability and having that principle in mind from the very beginning, but also keeping in mind you won't have all the information, and having that adaptability too, and having the resolve to be able to constrain the technology as we move forward to mitigate the risks.
It's very interesting to see, the way that these technologies are going to be structured in education because, first of all, things are moving so fast, right? That it's difficult to really pin down how exactly we should teach things and future proof people who are going to be working in fields that don't even exist yet, right? So I would say it's definitely a challenge, and I think it's going to require a more fundamental restructuring of the way we educate in the first place. As a matter of fact, I actually do have a separate episode on that with Ali, which I will link to in the description of the YouTube replay. And so if you'd like to learn more about the world of tech education, do click there. Also, I do see a couple more questions around blockchain and how it ties in with AI. We have already covered your question a little bit earlier in today's episode, but there is also another dedicated session on blockchain, so I will link to that in the description as well. Now, there is one more question that I want to ask. This one's from Tassin again. He's asking, are we developing AI to seek a deeper understanding of ourselves, and can we use AI to live more examined lives?
So let me give you this example. I don't know whether this is a deeper understanding, but I do believe that we talked about trust and ethics and fairness. I think we can use AI to more quantitatively understand the challenges that exist in society today, including biases. So even if you know for a fact that certain biases exist, to be able to address them, to take steps to address them, you need to be able to quantify them to know if you're making progress. And we struggle sometimes with quantification. So I'll give you an example of work that was done at our lab back in India, where they said, okay, we know that there is gender bias in movies from this generation. We knew that, nobody was not surprised. Could I put a number to it? Could I actually quantify it using AI? Because now I can repeat the analysis for today's generations and ask, have we moved along? Are the biases the same? And whatever those metrics are. So I do believe that while I don't think AI is going to tell you what should be, should you be biased, should you not be biased, how biased, that's moral, societal judgment. It's not going to tell you that. As human beings, we're going to have to decide. And morality has also changed. But it can help you quantify, because AI is good at analyzing data. So the data that's starting to become more and more digital can be analyzed. You can put numbers behind it, and you can ask yourself as a society, am I moving forward or not? And it is useful to do. So I think it can definitely shine a light on society. To the extent we want to improve, it is give us a measurement tool in my opinion.
Very interesting.
And also there is interesting work going on. It actually can go the other way too, where AI can help us understand human behavior, by the way, as well. So I do believe it is both way street, where human interactions teach AI, because that's the data that is used to train AI. And AI can help you understand human behavior too, because there are sort of very subtle patterns that go around that can give us some insight. And so to me, it is a both way street, whereas technology becomes better, it will actually, help us guide human behavior too. But again, what is morality is going to come from humans. AI is not going to define for us what is morality. And again, it is continuously evolving. What was moral, 2 centuries back isn't, moral today. Actually, we know this very well. And our morality continues to evolve. And it just from a human society point of view, that is something that is always evolving. But I do believe it is both way street. Absolutely. There are actually some very nice science magazine articles on this, on neural networks for human behavior understanding as well, and it's quite fascinating.
You're right, and I feel like being able to shine a light on, for example, bias and being able to quantify it is really important. Partly because bias is such a fundamentally human thing that it's difficult to get meta for a second and to think, what are we doing that's causing that bias, or how much bias exactly are we putting into data? Sometimes it makes sense, sometimes it doesn't. There's so many different ways to think about it. But as you know, our audience is incredibly diverse. We've got all sorts of folks joining in today. We've got developers, we've got people from business, we've got people from all sorts of different backgrounds, all different age ranges. And so before we end today's episode, there is a question I have for both of you. Is there a message you would like to share with the audience today?
Yeah, I can go first. Message to the audience: we are in very, very exciting times. So. And independent of age range, the only thing I would leave you with is be very flexible and open. The one thing that had actually kept me interested and had given me a very cherishing career has been never to be afraid to say, well, that's not my background, that isn't my space. Everything we talked about today was all about things getting intermeshed. So you could be a cloud guy, get into AI. You could be an AI, get into cloud. There wasn't a word called blockchain when I was graduating high school. So I could never, even if I wanted to, couldn't be a blockchain graduate. So if you're a security guy, get into blockchain, AI and security. So I think the biggest message I will leave with: don't be restricted to what you think are your swim lanes. Don't be restricted to what you think you should be doing, and it's not me, it's not. All of these technologies at their core are going to come together to solve interesting. You started in a swim lane maybe because it fascinated you, it was your choice. But be an avid explorer of all of these swim lanes, because eventually there's a big ocean here that is going to be fascinated, full of interesting fish that is worth fishing. So, go fish is what I would say there.
Thank you.
And I would say, actually, first and foremost, whatever you choose to do, enjoy what you do. I think if you are enjoying what you do, you're going to find the right threads and right connections to pull on. And whether someone is having a negative experience in the day they are at and things are not working out, and maybe this is just our experience. I think both Sriram and I have spanned multiple areas, as Sriram just pointed out. But every experience is teaching you something. Hey, that didn't work. Actually, I had a terrible time. So when you bump up against walls, don't get disheartened, because likely you are gaining more knowledge than you realize at that point in time, and it's going to come in very beneficial at some point later. Don't get disheartened. Truly enjoy what you do, whether it is music, whether it is mathematics, whether it happens to be science or not, irrespective. I think all these disciplines are getting so intertwined that if it happened to be truly music, just for the time being, you're going to find an intersection with robotics at some point, actually, and say, yes. You're going to find an intersection with symbols of music at some point as well. And again, I think it's all going to come together. So irrespective of what you pursue, enjoy what you do, and I think you're going to have fun in your life. So
Thank you. Thank you very much for sharing that, Ruchir. This is so insightful, and I feel like one highlight for sure is that when you bump up against a wall, don't be disheartened. And there are so many analogies I could pull from here, but there's one that I think people can really relate to, and it's the game of Hangman, right? If you were to do a mathematical analysis of the game of Hangman, which I actually have done, there will be a video on my channel on that shortly. If you do a mathematical analysis of that game, a lot of the times when you get a character that isn't part of the word, you end up gaining more knowledge about what word it could be over if you were to actually correctly guess a letter, right? Because it filters out more words that couldn't possibly be the answer. And so when you bump up against a wall, when you hit a roadblock like that, don't be disheartened, right? You're only gaining more experience, gaining more knowledge that's going to help you in ways that you really can't even fathom right now. So thank you very much, Sriram. Thank you, Ruchir. It was an honor to have you on the show today. This was super insightful, taking a look at how artificial intelligence has these symbiotic relationships with fields that you wouldn't even imagine, right? Like from a consumer's perspective, you don't think that cloud, you don't think that blockchain have anything to do with AI, but they do, and there's so much there. There's so much connective tissue that we really don't realize. And so thank you for your thoughts. It was absolutely incredible speaking with you two today. I'm sure the audience found this talk invaluable. So thank you for joining me, and thank you to everybody for actually joining the live stream. Again, really do hope you enjoyed. This stream is held every Sunday in the morning Eastern time as part of the TechLifeSkills series, so make sure you join us next Sunday as well. So once again, thank you, Sriram, Ruchir. Thank you everyone for joining in today, and goodbye, everybody.
Yeah, thank you.
Thank you.